Hello students and welcome to part 2 of Unit 6, Part 2, Lesson 1. Let's take a look at this graph and determine what type of correlation it has and what this correlation tells us about the relationship. We can see that the scatter plot below shows the number of snowboarding participants each year from 2001 to 2006. If we draw a line to show the general trend of this graph, we can see that it's moving upward. This is called a positive correlation. Now remember, a positive correlation says that as one variable increases, so does the other. So as the years increase, the participants have increased as well. So as the snowboarding competitions have passed or have occurred each year, okay, since they occurred each year, that means that we're going upward, increasing in years. The number of participants has increased as well. All right, let's do the same thing, except let's do it without a graph and think about what type of correlation you would expect. And we're also going to talk about why we think so. The average temperature in a city and the number of speeding tickets given in the city. Let's consider our options. Do they increase together? That would be positive. As one goes up, does the other go down? That's negative. Or is there no correlation? There's no real relationship between these two things. So, the average temperature in a city and the number of speeding tickets. As the temperature goes up, there will be more speeding tickets. Is that true? As the temperature goes up, the speeding tickets will go down? Or is there no real link between these two? Temperature does not indicate there will be a certain number of tickets. And that's our correct answer. There's no correlation between these two because just because it's warm doesn't mean there'll be more or less speeding tickets. Let's look at another situation. The number of ticket sales and the number of people in the audience. So do they both increase together, which would be positive correlation? Does one increase and the other one decrease? That would be negative correlation. Or is there no correlation? There's no link between these two. So the more tickets that we sell, the more people that will be in the audience. Is that true? The more tickets you sell, the more people that will be there? Yes, that is true. So this is a positive correlation because the more tickets we sell, the more people will be in the audience. The time a runner spends running and the distance remaining to get to the finish line. Do they increase together, which is positive? As one increases, does the other decrease? That'd be negative. Or is there no relationship, no correlation between these two items? So let's consider positive. The more a runner runs, the more distance it takes to get to the finish line. No. Let's try negative. The more a runner runs, the less distance that's left to the finish line. Yes, that's true, because the longer we run, the closer or the less distance it will take to get to the finish line. So that's a negative correlation. The temperature each day in Willow Hill, PA, and the number of cars sold each day in Los Angeles, California. So as the temperature goes up in Willow Hill, will there be more cars sold in Los Angeles? No. As the temperature goes up in Willow Hill, will there be less cars sold in Los Angeles? No. There is no relationship here, so we say there's no correlation. The weather here in Willow Hill does not affect the cars sold in Los Angeles. The number of members in a family and the cost of the family's grocery bill. So is it true that the more people in a family, the higher their grocery bill will be? Yes, so that means that's a positive correlation. Because the more people in a family, the more the cost of the grocery bill. The number of times a pencil has been sharpened and the length of the pencil. Well, let's talk positive. Increasing together. The more you sharpen your pencil, the longer it will get. Is that true? No. The more you sharpen your pencil, the shorter your pencil will get. Yes, that is true. So this is going to be a negative correlation, because the more you sharpen your pencil, the shorter its length gets. Let's look at one more example and then we'll summarize what we've learned. In this example, I want you to choose the scatter plot below that best represents the relationship between the age of a car and the amount of money spent each year on repairs. So first, let's think about if we're looking for a positive or a negative correlation. We're relating the age of the car and the amount of money spent on repairs. So is it the older the car gets, the more we'll spend on repairs? Or the older the car gets, the less we'll spend on repairs? It's this situation. The older the car gets, as the age of the car increases, we'll have to pay more for repairs. So we're looking for a positive correlation. That rules out graph C, because we can see that it is a negative correlation. That wouldn't make sense. The older the car gets, the less you have to pay to repair it. Now, we're looking at both graph A and graph B because they have a positive correlation. We can see that graph A occurs in both quadrants 1 and quadrants 2, whereas graph B only occurs in quadrant 1. We can see that this graph A has quadrant 2 because of this point right here. Can an age of a car be -4? Can a car be -4 years old? No. So it can't be graph A. The only graph that makes sense for this situation is graph B, because the older the car gets, the more the repairs will be. And we see that positive relationship there, occurring only in quadrant 1. So let's review what we've learned. We've learned that scatter plots are a type of graph used to display two sets of numeric data to see if a relationship exists between the variables. We've learned to create scatter plots by using ordered pairs that relate two sets of numeric data. We've learned that correlations show us how the two variables are related to each other, and we've learned that there are 3 different types of correlation: positive, negative, and no correlation, and that positive and negative can be strong or weak.